we will make two examples. The first one will include the layer pinching approach using the 3D layer configurator. I will start with a very simple geometry. Example one. This example, it starts from 2D. So we have a mesh in 2D, very simple. If you notice, I have in the super mesh, I have included an inner polygon. This inner polygon coincides by a regional fold. So I simply project the regional fold in the inner polygon. Later I will explain you why is this important for this case. To advance to 3D, so the standard approach in all the FEFLOW versions so far was to go to the 3D layer configurator. So we basically do the same here. But now the 3D layer configurator has different options. We can interact with the maps panel, which was not the case in previous versions. And I will add some informations. I will add two types, two files. The mesh, the 3D layer configurator works pretty simple. You simply need to drag and drop the elevation to the slice where you want to apply it. Or you can modify the elevation. At the moment, there is a mistake here in the units. Okay. Now we have one layer with the 3D layer configurator here. The model is still structural. Now let's complicate the situation. We can define different classes. The classes are actually telling the layer configurator what is the order, how to create the pinching of the different layers. So by default, we have movable and fixed classes. If we say fixed, this slice will not move during the interpolation. And now we can start adding additional information. So we'll add one slice with a distance of 50 meters in respect to the first one. I can see it here. I finish, I fix it again. Now I will add one slice in between. I have this slice in between, automatically split the layer in two parts. And this one will be my fold. I can simply drag and drop the fold, and now you can see that the slice elevation has changed because of the interpolation provided by this fold file. Is a .dat file. I'm satisfied with the fold, and now I start adding additional slices. So first I will add one slice below 3 to a distance of 250 meters, and then a distance of 500. So there I have continuous layers with, again, 250, and one more 500 meters. And this is my final conceptual model. So actually you can understand this 3D layer configurator as the place where you will set up your conceptual model, because here you can play quite a lot with the different elevations and see if the elevation, if the interpolation of a specific slice defines correctly the geological layer that you want to, how do you want to conceptualize this geological layer. And when you are done, because there is a intersection of these slices, comes this layer resolution. So we have different options. Now I will go to only remesh the complete layers, which contains the pinched elements, so the invalid elements. Depending on the complexity of slices or number of elements, The operation could take 1 or 2 minutes. And now we have the model domain here. Let's deactivate the hydraulic head and the faces. So I have only the edges. And here, as you can see, I have my incline at fall. This was the fall 1 file. We have a new panel called selection panel, and this panel stores the different informations between the layers and faces. So all the intersecting faces are stored automatically. We have the different faces, the meshing boundary. This is our faults. Now I have the face selection. If this will be the case that I want to place really a fault, very simple. I can simply say, because I have the selection active, I can simply create a discrete feature, and that's it. At the same time, FEFLOW provides very convenient options to bookkeep the information from the layer configurator. The different layers are stored as elemental selections here. If this will be my geological model, I can simply take the layer that I want and go to the data panel and assign a specific conductivity, for example. It's very simple. I have the information already there. You can create different slice intersections. There is no a maximum number of intersections. So this is a very simple case because of the time limitations, but we have tried several intersections as the plane that I showed you before. Intersection between slices in faults in different directions, this is also possible. What else you can do here is you can remesh the model domain. So you have your model domain here, but maybe you are not satisfied with this mesh discretization. So you can simply take the entire model domain and remesh it again. For that, we have a meshing panel. As I mentioned, we have different mesh generators. All of them is available here in the panel. Because we already have a 3D model and a structure, we use our meshing generator is TechGen, working from elemental selection. And if we would like to remesh the entire model domain, we simply need to drag and drop the different selections where you want to remesh. There are different informations that you need to apply depending on the type of mesh quality that you want to achieve. Typically, I will start with the global tetrahedron volume constraint. You can estimate what is the volume constraint of your tetrahedron easily because there is now access to auxiliary data parameter called elemental volumes. So you can simply see the elemental volumes of your tetrahedrals or get a rough estimate of this global tetrahedron volume constraint. So this volume constraint means that the mesh generator will try to create tetrahedrons with a maximum volume of this value that you assign here. For this example, I will give 1 to the 7. This will be the maximum volume of my tetrahedrals. And I'm doing a quality mesh, quite important. And simply press the mesh generator and the mesh is created. This operation, it takes 1-2 minutes. No. To save some time, we can simply go and see the result of the operation. And now you have the same model domain, but remeshed. We still have the different informations of the element groups, but each element group now has been subdivided in additional tetrahedrals. Now we have a better mesh, and we can clip our model and see what is inside. Let's clip it horizontally. We have the different tetrahedrals, and you have the detail. If you require more detail, let's say this section here, let's say this could be I don't know, a mining pit. you can simply select the elements that you have in this mining pit, drag and drop the elemental selection to the panel, and remesh. Why you're interested to remesh these areas? Because in most of the cases, you want to have a very good estimate of the pore water pressure around the pits, for example. Now you want to add additional constraints to the mesh generator. So one constraint could be, for example, I want to include a new system, a car system here. So I will simply need to go and say here, TechGent is my mesh generator, drop the elemental selection and include the new map that I want, cars points, for example, drag the cars points and remesh. We can take a look on the results. Deactivate this. No, sorry. This. You can see some things like this. You can nicely have, I will put there the other appearance. You can have now your car system inside the model domain, and we simply remesh one section of the model domain. If you want to include inclined wells, the same principle, you need to remesh your the location where you have your wells. So this is also example that we are doing in our training course. You can have your inclined wells. You either use the add in information to the panel as a line or as a points. Actually, it's easier to work with points because you avoid quite fast the problem of the safe intersection. If you have a very good discretization of the points, you can simply convert these to edge selections, and now you have your discrete features. And by the way, FEFLOW now support multi-layer wells, inclined multi-layer wells, so you can have your inclined multi-layer wells along these edges, as you can see here. Okay, let's do another example. There are a couple of questions that I will like to answer at the end altogether. The other example, we work with the approach of working with a geological model. So we create a new FEFLOW problem. We have two options. We go to the second one, full lead and extraction 3D meshes. Next, our super mesh will be constructed from maps. We can import a map here. Import. And this is a model, is a GoCAD 3D model, ML. We support different formats, as already mentioned. So we support Autodesk, 3ds files, LeapFrog, LFM, GeoModeler 3D, Gmod, GoCAD ML, GoCAD Surfaces, TS. In this example, I use the 3D model from GoCAD. Yep. You have no maximum number of files. You can add as many files as you want. The only thing that you need to care is the issue of the self-intersection. So you need to be sure that the quality, the data has acceptable quality. Finish, and automatically FEFLOW creates a 3D super mesh. So this is our 3D super mesh. You see all these very obtuse angles. Actually, these angles are not coming from us. They are coming already from the geological software. So this is also a point that you have to take care. If you have a very complex triangulated surfaces, no, also this will control the quality of your mesh. But we have possibilities to remesh again the model domain, so you can always end up with quality meshes from our tetrahedral mesh generator. The geological model has a different informations, so we automatically bookkeep the different informations, and we simply press on run. In this case, you can use also additional options. For instance, if your geological model has the surfaces, you can contain a column with the surfaces, and then you want to prescribe a constraint like 100% take the surfaces as it is, 50% can divide the surface area in up to 2, and if in case you want to make a refinement around your surfaces, we press the mesh generator button and just take a look on the results. And this is what we have at the end. As I say, the geological model has a different information. All this information is automatically bookkept in the FEM problem as an elemental selection. So we have different regions. So very easy then that you simply assign a material property to these parts of the model domain. We also have intersections between geological regions, so we can simply activate the phase selection, and we'll have the intersection to assign a discrete feature element. Yes, and you always have the possibility, as I say, to remesh and work again with this selection. So in this case, if I am not satisfied with a part of the model domain, again, I can combine the approach that I showed before with the meshing panel. So what is it? I can simply here drag the selection, and if I want to create remeshing in this area, I can simply indicate what is the factor here of a maximum constraint volume. And mesh again. Okay, that was everything from my side. Because of time constraints, there was not too much possibilities to show each detail of these workflows. No, I see from the chat that you are very interested to see the different files, no, and to get more details about the different workflows. So, because we have also received many requests from our users, all users, so we are providing a very unique opportunity of an online course to get started with unstructured meshing in FEFLOW 7. This course is especially for people who is already familiar with FEFLOW and they want to migrate the different models. So if you have a layer structure model that you want to reconstruct to pinch out some specific layers, or you want to get started with a fully tetrahedral using geological software. So in this course, I will try to show you these different workflows. I will try to explain you different problems of the input data, what is the best way to use your input data or set up your input data. So basically the course is divided in 3 sessions, already starting on March, because as I say, the quite high request from many customers. And this course is especially oriented to North America, South American users, so we have quite appropriate times. Nike is always 2 hours per each session, and the price is also quite comfortable compared to our standard courses. As I say, it's a very unique opportunity because we also want to help our users to get started and to migrate to the new FEFLOW. In case you want to register, so this is the email address for the registrations. If you want to get more information about the course, I invite you to visit our website, theacademy.dhi.com. You can simply select the filter FEFLOW and search our course and structure meshing in FEFLOW 7.0. In case any questions, you can contact our academy person here in Germany, or you can write my email. I will give you my email address at the end of the presentation. I think I answered all the questions. In case you still have a question, I will be happy to answer you. This is my email address. And if you have questions about the webinar, or if you have questions regarding to our online course. So on behalf of DHI Group, especially here in DHI-WASY in Germany, I would like to thank you for your participation, and until the next time. Have a good day. Bye.